welcome to Healthy Seminars. I'm your moderator, Lauren Brown, and our topic today is micronutrients for viral infections. And the original title was Separating Fact from Fiction During COVID-19. I think Mark's got an update title slide, so he'll share that with you momentarily. I just want to update you guys and give you some information to share with you. Let's see if I got what I got here. I don't think I have that one to open. I wanted to remind you guys that for your resources, you can go to Healthy Seminars and go to the resource page, and I'm going to take you there right now. And this is where you're going to be able to find the replay to this, as well as a past lecture that Dr. Mark Ratner has done. So on healthyseminars.com/resources, that's this page here where you see our calendar of events. So if you go to resources, anywhere up there, it takes you to resources. Any resource menu link will take you to the resource page. You can see our calendar of events, and there was the 11th and the 16th. If you click on that, then it will take you to the Theralogix page because they sponsor these two webinars, and you can find information on the webinar. This is where the replay for this will be, and you'll see below that the replay for the one in cannabinoids is already up, so you can watch that now. It's on this page, and there's some information from Theralogix as well. So if you want the handouts from the last lecture on cannabinoids and you want it on this lecture, then come to the Theralogix landing page at healthyseminars.com/Theralogix, that's IX. And here's where you can click and send them a link saying, I would like the slides, I'd like the handouts. And they said they'd be happy to send you that information. And they've also put other videos up for you as well if you want, looking for more research and more evidence. So I just wanted to let you know that's where you can find that information. Again, a big thank you to Theralogix for sponsoring these webinars, and a big thank you to Dr. Mark Ratner for offering this information. Dr. Ratner is the founder and chief science officer of Theralogix. He's been a practicing physician for more than 30 years, and he pursued his undergraduate studies and has a master's degree program in nutrition at Cornell University. And so it's always good to have Dr. Mark Ratner here. He's spoken at the Integrated Fertility Symposium in the past as well. And I like it because he likes to share the evidence. So it's nice to hear what the science has to say about some of the products and supplements that are out there. Just a disclaimer here. I just wanted to remind you guys that this is for educational purposes only. This is not medical advice. This should not be interpreted or perceived as medical advice. If you have a health condition, please seek out a healthcare provider. Again, this is for educational purposes only. All right, Mark, you can start to share your screen now.
Okay.
During the webinar, guys, feel free to put in the chat your questions. I'm going to moderate those. And Dr. Ratner's at about 45, 50 minutes of presentation. Then he'll take your questions as well. And if something's really relevant, I may interrupt him, but I'm going to let him, as best I can, get through his material, and then we can take the Q&A. And again, a big reminder that you can go to healthyseminars.com/Theralogix, and you'll find the replay here, the link to ask for the handouts, and to find out what special offerings they're offering as well with this webinar. All right, Mark, it's all yours.
All right, Lauren, thank you very much. So the first thing I just want to point out is that we have a slight change in the title of the presentation tonight, and we kind of gave a lot of thought to this notion of fact versus fiction, because it seems to perhaps imply that all of the answers are already known about this particular subject, and in fact they're not. And really what our goal is here tonight is to kind of teach everybody how they can go about separating fact from fiction, and develop a rational approach to the use of micronutrients in preventing and potentially treating COVID-19. So obviously we're living through something completely unprecedented, and this virus has taken over everybody's life. And if things are ever going to return to normal, science has to come to our rescue with a vaccine. The good news is there's something like 120 or 130 vaccine projects underway, and there's even things that perhaps will be ready sooner, things like monoclonal antibodies that will be a bridge perhaps to get us to a vaccine, which is probably at least a good year away. In the meantime, our patients are asking, besides the masks and the hand washing and the social distancing, what else can I do? Are there steps that I can take? What's this I hear about vitamin D and elderberry and zinc and all of these other things? It is a challenge for clinicians to separate what might work from what might not work. And even if you dig into the research, the answers are not always black and white. So again, today I'm going to try to explain how our company, Theralogix, has tried to answer this question. Basically, which micronutrients are safe and effective, and how are they best used? I'm going to start by trying to answer a simple question. How do we approach the use of natural products in the prevention and treatment of a viral infection? What kind of a framework can we use? To answer that question, we're going to have to understand the basics of viral replication, and as well how the immune system's response occurs to a viral infection. Then we'll explore a number of different micronutrients, and we'll look at both efficacy and safety. And finally, at the very end, I'll tell you kind of how our company sort of sorted through all of this and the product that has resulted from that process. So we basically have two different tools that we can use in this battle against viral infections. We've got antiviral agents, which are compounds that will directly interfere with viral replication. And we've got immunity modulators, which are basically compounds which will either increase or decrease immune system activity. That's what we mean by modulate. Modulate means it could go up, it could go down. Most of us have heard about the possibility that it's actually an overreaction of the immune system that gets us into so much trouble in the later stages of patients who have, severe COVID disease. And so we'll start off by talking about antiviral agents. And to understand antiviral agents, you have to kind of have a basic understanding of how viruses replicate. Okay, so we start off with this nice little host cell. And on the surface of the host cell, we see this little receptor. Now, there's also a virus involved here, and the virus, SARS-CoV-2, looks like this in the photomicrograph, and they call it a coronavirus because of this crown-like structure that surrounds it. And what that actually is, those are the spike proteins on the virus. Everybody has probably seen this diagram or something similar to it more times than they care to remember. But real quickly, what we have in the center is RNA. Okay, the viral genome. The RNA is packaged in what's called capsid proteins. It's held together by these capsid proteins. There's an envelope. Coronaviruses are what we call enveloped viruses, which means they've got a cell membrane. And embedded in that cell membrane are these spike proteins. And so the first step of viral replication is attachment. And with the COVID-19, what happens is the SARS-CoV-2 virus spike protein binds to a receptor on the cell surface, which is called ACE2. ACE2 is angiotensin II converting enzyme. And so it binds to that little receptor. And then what happens is it invaginates. The virus kind of pushes into the cell and a little pocket forms. We call that pocket an endosome. And so that's the first step, attachment, and then entry. The virus enters the cell by a process called endocytosis, and it forms an endosome. And the endosome has fluid in the center of it, which must actually then develop an acidic pH to activate the virus. So here's another view of that. You've got the virus, and it binds to the surface of the cell. It pushes in. You've got the ACE2 enzyme, which is the receptor, and the spike protein on the virus. And then it forms this little bubble, this little vesicle, which is called an endosome. And there's an enzyme inside the endosome called cathepsin. Cathepsin is what activates the virus. It essentially allows the RNA in the virus to break free. And for cathepsin to work, the environment inside that endosome must be highly acidic. And so when that happens, the endosome opens up, the RNA comes out into the cell, and then the cell can take over, the virus can take over the cell and basically turn the cell into basically a virus factory, because that's ultimately the goal for the virus. So you get genome replication and gene expression. So the viral genome, which is RNA, is copied, and then some of those copies are used to make viral proteins. Now, the enzyme that does the copying for SARS-CoV-2 is called an RNA polymerase. And so that process, you've got entry into the cell, the capsid comes apart, the RNA is released, you get replication of the RNA, and you get production of the viral proteins. Next step is assembling new viral particles. And so what happens is those RNA copies and the viral proteins assemble into new viruses, which are then released from the cell, and off they go to infect more cells. So this is a process that's the last step is called release, right? And so this is a process that the SARS-CoV-2 virus is really good at, and it's actually devised mechanisms that bypass the typical defense steps that cells will take against a virus. So if we look at those 5 steps: attachment, entry, replication of the RNA and gene expression, assembly, and release, we can understand how some of the antiviral drugs that we're reading about might work. If we go back to this little diagram, the drug that we've all heard probably the most about, hydroxychloroquine, this is an approved drug. It's being used as an antimalarial. It's also being used to treat patients who have lupus. It primarily works by preventing the pH of the endosome from dropping. And by making the inside of that endosome more alkaline and less acidic, it keeps the virus from being activated. It also can help reduce attachment of the virus, the spike protein to ACE2, and it can also block some aspects of protein and viral assembly. So does it work? Well, the studies on hydroxychloroquine have all been done so far on patients who've been pretty sick. The study that was done at the White House with an N of 1 didn't really prove very much at all. But they do have to do more studies with hydroxychloroquine looking at its use early in infection. There's a drug that we've heard about also called remdesivir, and remdesivir blocks RNA polymerase. It's actually an adenosine analog, and what that means is it takes the place of one of the building blocks of RNA, and it basically fools RNA polymerase into incorporating an analog so that RNA transcription stops dead. So it basically stops RNA reproduction, the viral RNA from reproducing. There's a drug called ivermectin, which is an antiparasitic drug that's been around for many, many years. It actually prevents the processing of viral proteins, and it's now being studied in several clinical trials around the world because there's some evidence that if you can get a high enough dose into people, this can dramatically reduce the reproduction of viral particles. Finally, there's something called camostat mesylate, which is a drug approved in Japan for treating chronic prostatitis. And what it does is it basically screws up the spike protein so that the spike protein loses its shape and it can no longer bind to the ACE2 receptor on the cell. And so that's being tested as well. So all of these are antiviral drugs that target different aspects of the viral replication process. And what we're going to see is that there are actually some micronutrients that work in exactly the same way. So those are antiviral agents. What about immunity modulators? And once again, to understand how something might modulate the immune system, we need to understand how the immune system responds to a viral infection. So there are basically 2 parts to our immune response. There's what we call innate immunity, and there's something called adaptive immunity. And I want to just take you quickly through those so that you can understand how things work and how things then sometimes don't work, and how we can affect each of these aspects of the response. So innate immunity is a fast-acting generic response. It happens very quickly. It's non-specific. Whenever the system basically detects any invader, basically it's really mounted within hours of the first detection of an invader. No time is wasted. The system doesn't have to know exactly what the pathogen is. It's a non-specific attack on anything that seems foreign. And as I said, it starts within hours, and it usually just lasts for a few days. It involves the coordinated action of a bunch of different white blood cells, neutrophils, mast cells, monocytes, natural killer cells, phagocytes. Each of these do different things, but they basically are mobilized quickly, and this initial innate response happens within hours. It starts. Cytokines play a very important early role. Now, most of us have heard this term cytokine because there's something that can go wrong with cytokines, which we'll talk about in a moment. So what is a cytokine? A cytokine is essentially a very small protein that's secreted by immune system cells. And those cytokines serve as chemical messengers. Cytokines are, it's a catch-all phrase, and it includes several different types of messengers. So there are more than 40 different what we call chemokines. And these are messengers that are secreted by one type of white blood cell. And the goal is to attract other immune cells to the area where the pathogen has been detected. Interferons, which we've all heard of. And there are 3 different interferons, alpha, beta, and gamma. Interferons actually directly interfere with viral replication, another type of cytokine. There's something called interleukins. Interleukins are messages that communicate between white blood cells. There's 15 of them, and some of them are pro-inflammatory. There's like one called IL-6, which has really been implicated in a lot of the damage that happens to the lung in COVID-19. And so the abbreviation for interleukin is IL. So there's IL-1, 2, 3, all the way up to 15. Some of them are pro-inflammatory, and some of them are actually anti-inflammatory. And finally, we have what we call tumor necrosis factors, which are cytokines that can actually directly kill a bacteria or a virus. So if we look back at the little diagram of viral replication, interferons, which can directly interfere with viral replication, they work in several different areas. They can actually prevent entry of the virus into the cell. They can interfere with processing of the viral proteins, and they can actually interfere with assembling of the new viral particles. But cytokines, interestingly, are produced both during the innate response and then in the early part of the adaptive response, which we'll talk about in a minute as well. Another very, very important portion of the innate immune response, another player, is what we call antimicrobial peptides, or AMPs. Now, AMPs are, again, small peptides which the white cells produce, and they actually act as body-owned antibiotics. The 2 primary antiviral AMPs, one's called cathelicidin, and the other is actually a group of them called defensins. And the way they work is that they actually can just directly destroy bacteria and enveloped viruses. That's viruses that have a membrane around them by disrupting that cell membrane. So they are a critical part of that initial innate immune response. But the really fascinating thing, and this is going to be a sort of a little sort of preview of what we're going to be talking about with vitamin D. In order for the body to produce antimicrobial peptides, there must be adequate vitamin D in the cells. And so adequate vitamin D levels in the white blood cells are required for production of antimicrobial peptides. So the innate response goes on, typically lasts about 4 to 7 days, and towards the end of the innate response, the white blood cells do something called antigen presentation. And what that means is they take some of the proteins from the virus and they put those proteins on the surface of the cells. This is typically macrophages and phagocytes. And what they do is they then show those antigens to lymphocytes. And the lymphocytes, B lymphocytes and T lymphocytes, then take over the adaptive immune response. So that's the second phase. Adaptive immunity is delayed. It usually starts 4 to 7 days after the innate response has started. Again, the innate response was immediate, non-specific. It's just like, you don't belong here, and we're going after you, okay? The adaptive response is highly targeted. Pathogen-specific antibodies are produced primarily by B lymphocytes, and they attack that specific pathogen. And so if we look at it on a timeline, what we see here is that in the first few days, during the innate response, we're seeing a lot of interferons produced, antimicrobial peptides, chemokines are released to bring additional white blood cells into the area. And then after a few days of the innate response, we start to see the production of inflammatory cytokines. And then towards the end of innate response, we see antigen presentation. And we then start to see the production of B and T lymphocytes, which will produce antibodies. And so this adaptive response kicks in typically 4 to 7 days after the infection has started, and it involves the production of antibodies. What are antibodies? They are specialized proteins which then bind to the viral particles, complex them, and then those viruses that have been bound up by the antibodies can then be destroyed by other immune system cells. So the B and T lymphocytes, which are making these antibodies, some of those B and T lymphocytes develop into what we call memory lymphocytes. They develop a memory of that specific antibody that is being produced against the SARS-CoV-2 virus, let's say. And those memory lymphocytes are stored in and they stick around for years, hopefully. And that's what allows the body to then quickly produce antibodies if it detects that same infection, that same virus in the future. So the production of these memory B and T lymphocytes is really important. And this is what an effective vaccine produces, the production of these memory lymphocytes, so that we're ready. Don't have to wait for an innate response. We can jump right into an adaptive immune response and produce antibodies if we start to see that virus again. So if we go back to this little timeline, one of the things that you see here is as antibodies start to get produced under normal conditions, the cytokines that are being released start to tail off. And so sometimes, though, this doesn't happen properly, and we end up with what we call cytokine storm. Okay, so cytokine storm is going to occur when the normal regulatory mechanisms that are supposed to make the cytokine release decline don't kick in. And these mechanisms can break down, and then you get an oversecretion of pro-inflammatory cytokines like interleukin-6, interleukin-8, tumor necrosis factor alpha, okay? And all of these pro-inflammatory cytokines start to basically result in local tissue damage and organ damage. And so a lot of the damage being done to the lung and the gut and the endothelium, the blood vessels, in COVID-19 severe cases, it's being done by this excess production of cytokines. So when we talk about immunomodulation, the goal here is to balance the immune response. You want to support and enhance the early innate response and antibody production, but you want to reduce the risk of cytokine storm. Okay, so what can we do in terms of micronutrients to basically try to find some interventions that can achieve that? Well, our company, Theralogix, we are kind of under the auspices of a medical advisory board. And this board has been with us for close to 18 years. It includes 15 full-time faculty people from a bunch of medical schools around the United States, including the chairman of clinical immunology and rheumatology at the University of Maryland. So what happened was the very end of March, Dr. Hochberg, who is the clinical immunologist at Maryland, he brought our attention to a protocol that had been published by Eastern Virginia Medical School. It was published in late March of 2020, and it was developed by their Department of Pulmonary Medicine and Critical Care at EVMS, Eastern Virginia Medical School. They identified in this protocol multiple evidence-based micronutrients that they proposed for use in both the prophylaxis, the prevention, and the treatment of COVID-19. So Dr. Hochberg brought us this protocol. He brought it to our attention. The protocol basically had dosing recommendations for both prophylaxis, potentially before you've been exposed, after you've been exposed, but for prevention, and then even had proposed dosing for active treatment for patients who perhaps were in the hospital. That protocol focused our attention on 5 nutrients, and our board and the rest of the company focused initially on looking at these 5 nutrients: vitamin D, vitamin C, zinc, quercetin, melatonin. When we realized that we wanted to really kind of roll up our sleeves and dig in here, we expanded the things that we were going to look at, and we added a few extra nutrients that we thought, at least had a lot of information out there in the public domain: elderberry, colloidal silver, hesperidin, licorice root, and astragalus. And so we kind of dove in and tried to really analyze what we could about these micronutrients. And we really took an approach trying to answer 6 questions. The first is obvious. What is it? Okay. I mean, some of these things, yeah, it's obvious what they are, but not everything. At least not to us, it wasn't. What is the mechanism of action? Is there published evidence? And what does it look like? What dosing has been suggested? Is this a safe intervention? Not something that we can take for granted. And then, how is it being used clinically? How is it best applied clinically? And so what I want to do is take you through some of these nutrients in depth and kind of use that little format. So vitamin D. I'm starting with vitamin D because I think it's probably the most intriguing and the most exciting of any of these nutrients at this point. Vitamin D is a fat-soluble vitamin, right? We all know that. But actually, there's a whole school of thought that says vitamin D may not even be a vitamin. It may actually be a hormone. And the reason that some people say that is because we produce vitamin D in our skin in response to ultraviolet B light. What's the definition of a vitamin? A vitamin is a compound that we cannot make in our bodies and we must get from our diet. What's a hormone? A hormone is a substance that we make in one part of our body that then acts in other parts of our body. And it's arguable that vitamin D really better suits the definition of a hormone than it does a vitamin. Years ago, we were taught that the only real purpose of vitamin D was to enable absorption of calcium and calcium metabolism to help build strong bones. Today, we know that vitamin D actually serves as a nuclear transcription factor for over 1,000 genes. There literally is not a cell in our body that does not have a vitamin D receptor on its surface. So what's the mechanism of action for vitamin D in terms of viruses? Well, there's actually no evidence of any kind of direct antiviral action. If we go back to those 5 steps, vitamin D doesn't seem to really interact anywhere along that process. But the immunomodulatory activity for vitamin D has become really well established. The first thing is, and we mentioned this a couple moments ago, it is an essential nuclear transcription factor for the production of antimicrobial peptides. So those AMPs, which are a critical part of the initial innate immune response, require the presence of vitamin D in order to be produced. So vitamin D plays an important role there. One of the things it also does is it enhances and promotes the shift between innate and adaptive phases. So that portion of the innate phase, late, where it starts to present the antigen to the lymphocytes, that is really enhanced by the presence of vitamin D. It modulates overactive white cell activity for certain types of white cells. And it also reduces the production of pro-inflammatory cytokines like interleukin 1, 6, and 8, and tumor necrosis factor alpha. So vitamin D is truly immunomodulatory in that it enhances some aspects of the immune response, the ones that we sort of want enhanced, and it probably downregulates some of the ones that are best kept in check. So what's the published evidence? Well, before we can talk about that, I want to digress 1 second and make sure everybody is sort of completely up to speed on how we measure vitamin D status, because it's one of the few vitamins that we can actually not have to guess. We can actually essentially check your status and see where you stand. So there's a blood test, and the blood test is called a 25-OHD. And it's a simple blood test. It's almost, you know, as readily available as something as a cholesterol level at this point. What constitutes a normal 25-OHD? Well, in 2011, the Institute of Medicine, which is a quasi-public entity here in the United States, they published their opinion that a normal level for vitamin D, a normal 25-OHD, was anything over 20 nanograms per milliliter. And if you were below 20, you were deficient. Several months later, the Endocrine Society said, not so fast. We think that normal is 30 nanograms and above. And that if you're between 20 and 30, that's insufficient. And that frank deficiency is agreed below 20. But the Endocrine Society said, we want to see people at 30 or better. So why did they disagree? You know, these are two organizations that you would think, you know what they're doing. It turns out that the Institute of Medicine had based their recommendations purely on the data for bone health and vitamin D, and ignored all of its other potential activities in the body. The Endocrine Society, on the other hand, looked at a wide range of data, and there's some really interesting data on what's called all-cause mortality. So this basically is a study that looked at vitamin D levels, and this was the vitamin D level along the bottom, and on this axis, this was the risk of dying, okay? And here is a risk of 1, and anything that is above here means you have an increased risk of dying. And so what this graph tells us is that if you have a level below 30 and 40, you've got an increased risk of all-cause mortality. And that doesn't really flatten out until you reach about 40 nanograms per milliliter. So there is benefit in being at 40 or above compared to being below. This was one study that was published back around 2015. Now, you would think this would be absolutely conclusive, and what it would really say is, doesn't matter how high you are, the higher the better, because there's no damage. But there's another study that got published, same exact kind of data. They looked at all-cause mortality on this axis and vitamin D levels here. But it showed what we call a reverse J curve. And what that means is, yes, if you're really low, as you get higher on your vitamin D level, your risk of mortality goes down. But then once you bottom out, as you go to higher levels, it starts to go back up. And so what this is saying is, being really high on your vitamin D level may be just as bad as being very low. And so it's basically saying there's a sweet spot in the middle. And this is still a point of contention in the vitamin D world. Although I think more people believe that this curve, the reverse J curve, might have been really the result of artifact. One of the things you can see here is that the standard deviation, this big line here at the high levels, the standard deviation goes up so much that it may just not be very reliable data. Okay, so whether you believe that 30 to 40 is where you want to be, or you believe you could even be higher, the fact remains that 60 to 70% of US adults are actually below 30 nanograms per milliliter. And I would say it's probably that bad or worse in Canada because there's less sunlight at northern latitudes. And so this is an issue, and we want to restore people. Why can't we do it easily? And why are so many people below where they should be? It's because we spend a lot of time, at least in northern latitudes, bundled up, a large part of the year bundled up. And the unfortunate thing is there are really no widespread food sources for vitamin D. Fatty fish, like wild salmon, probably the best source of vitamin D that we know. But unfortunately, to have an adequate intake and bring your level up to the normal range, you'd need to eat about a half a pound a day of wild salmon. So it's not something that most people can achieve. It basically means we have to supplement. Okay, so what's the published evidence? Well, there's extensive mechanistic support for this immunomodulatory role of vitamin D. And a 2017 study that was published was a meta-analysis. There had been about 24 randomized controlled trials with over 11,000 patients done where they looked at whether or not vitamin D supplementation would reduce the risk of a viral upper respiratory infection. And the data basically showed that there was a statistically significant reduction. This is the data from that meta-analysis. Each of these blue dots represents one of those 24 studies. It's called a forest plot, and any study where the blue dot is to the left of this line that says 1 means that supplementation reduced the risk, and any blue dot that's to the right of this line that is at the 1 mark here means that it increased the risk of supplementation. And so it's pretty clear. Vitamin D supplementation reduces the risk of viral upper respiratory infections. There were some interesting results that came out of this meta-analysis. The first was obviously the subjects that had the lowest starting point vitamin D levels saw the greatest benefit. But the other thing that was so interesting was that studies that used large intermittent boluses of vitamin D, where they try to give 100,000 units once a month or something along those lines, those studies don't show any benefit. So large intermittent boluses don't work. You really want to bolus either daily or at the very most weekly in terms of vitamin D intake. There was a Swiss study in COVID patients just published 2 months ago. And they basically tested vitamin D levels in patients who had presented at government clinics with upper respiratory infections. And what they found was that patients who had positive PCR COVID tests, their average vitamin D level was 11. And the patients who tested negative for COVID, their average level was 24. But probably the most amazing study in terms of vitamin D was just published 2-3 weeks ago. And I shouldn't say it was published. It was actually pre-published. This is a preprint release of this study from the Philippines. And there's a lot of preprint stuff that's getting out these days without peer review yet. I'm really hoping that this holds up because it's an astonishing study. What they did was they retrospectively went back and they looked at COVID admissions for 3 different hospitals. And they then they had about 200 patients, and they divided them by the severity of their illness. The patients either had mild disease, what the investigators called ordinary, which is really sort of moderate disease, severe disease, or critical disease. And they said, okay, for each of these 4 things, what was the average serum 25-OHD in each group? The mild patients, their average vitamin D level was 31. Patients who had moderate disease, their average vitamin D was 27. Severe disease was 21. And critical patients had an average of 17. Other way to look at this was to say, okay, in each of these 4 clinical groups, what was the normal percentage? What percentage of these patients in each group had a vitamin D level that was 30 or above? In the mild group, 86% of the patients had a normal vitamin D level. In the moderate disease group, it was 7.3%. And then in both severe and critical, it was roughly 4%. So this is a really, and both of those trends were statistically significant. This is really compelling evidence, if it holds up, that having a normal vitamin D level is very protective if you do end up picking up the virus. Dosing, well, the Institute of Medicine recommends 600 to 800 units daily. The Endocrine Society says, no, that's too low. You can go anywhere from 1,000 to 4,000 units daily. In terms of safety, the Institute of Medicine says up to 4,000 per day is safe. Endocrine Society says that's too low. Up to 10,000 units per day is safe. So how do we get patients who are low back to a normal range? Okay, so here's a very simplified repletion protocol for vitamin D levels. If a patient comes in and their vitamin D level is between 25 and 30, if they take 2,000 of D per day for 8 weeks, you'll get them back into the normal range. If they're between 20 and 25 nanograms at baseline, 4,000 per day. If they're 15 to 20, 6,000 per day. And if they're actually below 15 nanograms per milliliter at baseline, they need 8,000 per day for 8 weeks. And this should get most people back into the normal range. Once people are back in the normal range, 2,000 per day is really excellent for maintenance. It's a great maintenance dose. Clinical use of vitamin D, optimal rate, where do you want to be? You want to probably be between 35 and 50, okay? Because the reverse J-curves sort of dilemma has not completely been settled, you probably don't need to be higher than 50 nanograms per milliliter. Everyone should know their vitamin D level, have your patients get checked. It's daily dosing, not bolus dosing. Once you are replete, the maintenance dose is 2,000 units a day, and like all fat-soluble vitamins, they are going to be best absorbed if you take them with food. Okay, let's move on. Vitamin C. What is vitamin C? Chemical name is ascorbic acid or ascorbate. It's a water-soluble vitamin. It is a very potent antioxidant, but very interestingly, the levels in our tissues and in our serum decrease dramatically during stress or illness. And that decrease is probably what's responsible for the vitamin D data on severity and duration of colds. So what's the mechanism of action? Once again, no evidence of a direct antiviral effect, but from an immunomodulatory activity perspective, it has some real benefits. Vitamin C is concentrated in certain white cells, neutrophils, lymphocytes, macrophages, to levels that are more than 50 times higher than what's found in the serum. And it's believed that's because the antioxidant effect is needed to protect those cells. It increases the production of interferons alpha and beta. It increases the differentiation and proliferation of T and B lymphocytes. And so there's a lot of published evidence about vitamin C. One of the earliest studies that really kind of triggered the interest with Linus Pauling and the common cold was done back in Europe in 1970. It was published. Basically, they looked at patients who were hospitalized with pneumonia. And it turns out that if you gave them between 250 and 800 milligrams of vitamin C by mouth daily, you could decrease their hospital stay by 19%. And if you doubled that dose, you would reduce their length of stay by 36%. 20 years later, there was a study which kind of confirmed this. It basically said only 200 milligrams per day of vitamin C could significantly reduce the symptoms and improve outcomes in hospitalized pneumonia patients. So how was that happening? Well, it turns out that in 2004, it was discovered that vitamin C levels rapidly and significantly decline in individuals once they contract a viral respiratory infection. And so a meta-analysis that was published, what we call a Cochrane meta-analysis, was published in 2013, which basically showed that taking 200 milligrams per day or more of vitamin C will reduce the severity and duration of the common cold. But it only reduces the incidence of the common cold in a subset of individuals that had increased stress. And by stress, what they meant was these were marathon runners, soldiers who were living in an extremely cold environment, things that would normally decrease the amount of vitamin C in the tissues, in the serum. If you supplement those people, you can reduce the chances they'll get a cold. But there's clearly benefit in terms of reducing the severity and duration of a cold if you start vitamin C once the cold has started. So dosing. Well, the current recommended daily allowance of vitamin C is 75 milligrams per day for adults over the age of 19, but the government data on this from 2016 said that roughly 45% of US adults don't achieve the recommended daily intake and are at risk of deficiency. If you smoke, if you have a poor diet, if you have an illness, you're going to significantly reduce the blood levels as well. What about safety? Well, it's a water-soluble vitamin, so basically you just pee out the excess. You know, as we say, you just get very expensive urine. But there are some issues, and the problem is that vitamin C, when it gets into the urine, is metabolized to oxalate. And so if you take more than 1,000 milligrams of vitamin C per day on a continual basis, and you are prone to kidney stone formation, you're going to make calcium oxalate kidney stones at a much higher risk. Okay, clinical use of vitamin C. Well, for prevention, there's really very little evidence that supports daily doses greater than 500 milligrams. But if you develop an active infection, whether it's the flu or a common cold or COVID, higher doses of 1,000 to 2,000 milligrams per day may be beneficial while you're ill. There are actually several clinical trials going on right now looking at intravenous vitamin C for patients who are in ICU with COVID. And we're talking about doses being given intravenously of anywhere from 10 to 20 grams per day. So, and that's not only safe, but it looks like it's probably going to be effective in certain situations. Interestingly, people will say, well, you know, why can't you just take more than 500 in a day? Because you cannot absorb more than 500 milligrams of vitamin C in a single oral dose. Higher daily intake requires divided dosing. Okay, zinc. What is zinc? It's an essential mineral. It's the second most common trace metal in the body after iron. It's involved in numerous aspects of cellular metabolism. It's a cofactor for many enzymes. How does it work? Zinc has direct antiviral effects. It's active against the flu, rhinovirus, HPV, coronavirus. It downregulates the expression of ACE2, which is the receptor on the cells. It also inhibits the activity of RNA polymerase in SARS-CoV-2. So that means it helps to decrease the viral replication of its RNA. If we look at that diagram again, it blocks attachment and it reduces viral RNA replication. It also has confirmed immunomodulatory activity. It can enhance the recognition of pathogens by those innate immune cells. It upregulates interferon secretion. It promotes differentiation of T and B lymphocytes. And there's a ton of published evidence about the benefits of zinc. We know that zinc deficiency in older adults is common, and that may worsen the age-related decline in immunity. 30 milligrams of zinc supplementation in adults older than 65 significantly increases the concentration of certain types of T lymphocytes. 45 milligrams daily reduce the incidence of respiratory infections and the levels of inflammatory cytokines in nursing home patients. And zinc levels are inversely correlated with the risk of pneumonia in older adults. You have a 50% lower risk if you have a normal zinc level. Finally, everybody is aware of cold E's, which are zinc lozenges. And it turns out that a meta-analysis of 7 randomized trials confirmed that those lozenges will actually reduce the duration of the common cold by 33%. That was published just 3 years ago. Dosing for zinc. The current RDA is 11 milligrams for men and 8 milligrams for women. There are multiple zinc salts available. Zinc picolinate and gluconate appear to be the best combination of absorption and tolerability. High doses of zinc can cause some GI upset. It is relatively safe. The upper limit that's set by the Institute of Medicine is 40 milligrams per day. There used to be a product called Zicam. The original Zicam was an intranasal gel, which was pulled off the market because if you squirt zinc gel into your nose, you will lose your sense of smell. Not a good thing. So there is still Zicam, but that's a zinc spray that you can put into your throat. Long-term intake by mouth of more than 40 milligrams per day creates the risk of copper deficiency because it blocks copper absorption from the diet. So clinical use. For prophylaxis, the evidence doesn't really support doses higher than 40 milligrams. But during an active infection, higher doses, maybe 50 to 100 milligrams, can be beneficial for several weeks. If you're going to supplement with intakes at 40 or higher, you should probably also supplement with copper to prevent deficiency. Okay. Quercetin is a dietary flavonol, which is basically a polyphenol that is found in many different fruits and vegetables. There are lots of different flavonoids. Flavonols are one type, and quercetin is a flavonol. It is a potent antioxidant and anti-inflammatory, and it has direct antiviral effects in vitro. It is an inhibitor of the main protease of SARS-CoV-2. What that means is the enzyme that helps process the viral proteins gets blocked by quercetin. It also strongly binds to the spike protein, and it blocks viral attachment. So if we look at quercetin, it can block attachment, and it can block processing of viral proteins. And it also does the same blocking of entry for influenza A. So quercetin has some really great benefits here. It also has well-established immunomodulatory benefits. It'll upregulate the production of interferon gamma. It reduces the production of pro-inflammatory cytokines, and it downregulates certain types of overactive immune responses as well. So what's the published evidence? Well, it has specific COVID-19 cell culture evidence of antiviral benefit, which is really exciting stuff. There's a study from 12 years ago where they actually gave these poor little mice influenza, but if they treated them with quercetin ahead of time, they got a dramatic reduction in their symptom severity and mortality. There's a study with 40 cyclists that were dosed with 1,000 milligrams of quercetin daily for 3 weeks, and that reduced the incidence of upper respiratory infection. In a placebo-controlled trial, 500 to 1,000 milligrams per day reduced the total number of sick days and symptom severity in upper respiratory infections in subjects over the age of 40. This data basically shows that you get a benefit at 500 per day and a little bit more benefit at 1,000 per day in both duration of symptoms and severity of symptoms. Dosing of quercetin, well, obviously it's an herbal, there's no RDA or upper limit. A typical North American diet provides 10 to 15 milligrams daily. Studies have used anywhere from 500 to 1,000 milligrams daily. It is safe, although there are no studies of longer than 12 weeks with 1,000 milligram per day dosing. The side effects are generally mild and infrequent, but there are reports some people get headaches, mild GI upset, or actually some tingling in their arms and legs from high doses. It can cause some drug interactions, so patients should check with their healthcare provider. And in terms of clinical use, for viral prophylaxis, 500 milligrams daily will raise serum levels, but avoids the potential risk of long-term intake. Short-term intake of 1,000 milligrams is probably safe, and it's best taken with food for absorption and also with vitamin C, which protects it as an antioxidant. Melatonin, the last of the 5 I'm going to cover in detail. Obviously, it's an endogenously produced neurohormone secreted by the brain, the pineal gland, in a circadian rhythm. It's also found in certain vegetables, fruits, and nuts, which is why we can make it as a supplement. The mechanism of action, no direct antiviral activity, but it's pretty clear that melatonin buffers the immune system. It's a potent antioxidant. It enhances the immune response by directly proliferating and maturing T and B lymphocytes, granulocytes, and monocytes. And it reduces the release of pro-inflammatory cytokines and increases the release of anti-inflammatory cytokines. Published evidence, most of the trials with melatonin obviously have been used for sleep disturbances, but there are multiple studies that show a lung protective benefit in pneumonia models. A meta-analysis of 22 human clinical trials demonstrated that it reduces pro-inflammatory cytokines like tumor necrosis alpha and IL-6 and upregulates anti-inflammatory cytokines. It actually may interfere with SARS-CoV-2 binding. That's still experimental and mechanistic data. And here's a really interesting study that was done with patients who were in ICU who were given melatonin. They had a 68% reduction in what's called ICU delirium. Patients who are in ICU oftentimes get what we call ICU psychosis, where they can't tell day from night and they become basically demented on a temporary basis. There are currently 2 randomized trials going on with melatonin for prophylaxis of COVID. So there's no RDA or upper limit For sleep disturbances, 2 to 5 milligrams is generally considered safe. You have to beware though, because there was a 2017 study that looked at 31 commercial melatonin supplements. 71% of them were out of range from their label claim, and 26% of those contained detectable amounts of serotonin. Patients who are taking anti-seizure or anticoagulation medication should talk to their healthcare provider, and side effects are usually infrequent, but obviously it's going to make you sleepy, so you should take it at bedtime. 2 milligrams is a good dose, but during active infection or hospitalization, you can increase to 5 or 10 milligrams, and obviously you want to take it before bedtime because it's going to make you sleepy. Okay, elderberry, colloidal silver. What is elderberry? It's a genus of flowering plants. There's more than 25 different species. It's rich in a type of flavonoid called anthocyanins, but the major bioactive compound is cyanidin-3-glucoside, which has some problems associated with it, which I'll mention in a second. It's reported to inhibit the replication of influenza, but the mechanism hasn't been clarified. It does have antioxidant activity. But interestingly, elderberry contains a very high concentration of quercetin. It does, however, and this is important, it increases the release of pro-inflammatory cytokines IL-6, 8, and 2-necrosis alpha, and that's not a good thing late in the stages of COVID. So, published evidence, there's really no published data regarding coronaviruses. There are 2 studies that have looked at influenza and the common cold, and what they both showed was that it can shorten the duration of symptoms, but it will not reduce the incidence. Finally, a meta-analysis was published 3 years ago, which essentially looked at 4 different studies, which showed that if you start elderberry at the onset of upper respiratory symptoms, you'll get some benefit, but that there's no evidence that it can reduce the chance of actually getting the upper respiratory infection. So what about dosing? You can get elderberry as a liquid, as capsules, or as lozenges. There's significant variability in extract strength and dosing. And most studies have used either 3 times or 4 times per day dosing. In terms of safety, incorrectly processed forms of elderberry can be very toxic because this cyanidin-3-glucoside can be converted to hydrogen cyanide, and people have actually ended up in the emergency room because of this. Most importantly, there is concern about the possible worsening of cytokine storm for patients taking elderberry who then develop COVID, because it does upregulate pro-inflammatory cytokine release. So, clinical use. There's more than 24 species of elderberry. They have varying bioactivity. There are side effects. It interacts with diabetes and COPD medications. The safety of long-term use is unclear, and it may worsen the risk of cytokine storm in COVID-19 patients. So, colloidal silver. Colloidal silver, tiny particles of silver metal suspended in a liquid. Not found in the human body. Silver is not an essential mineral, but it is recommended by some practitioners for oral use as an antimicrobial. Historically, it has also been used topically to aid wound healing. What's the mechanism of action? Well, it may actually inhibit bacterial growth in cell culture, but there's never been shown to be any activity against viruses or fungi. No published mechanistic or clinical activity of antiviral activity. No published evidence of immunomodulatory activity. And there's really no published data for either prevention or treatment of viral infections. Even though Gwyneth Paltrow at Goop and Alex Jones at InfoWars love it, we basically have to look at the literature and decide whether or not there's enough support here to kind of risk the use of this. Amazon, nevertheless, has over 300 listings under colloidal silver at this point. Lots and lots of products out there. Dosing, well, there's different strengths by parts per million. There's no dosing recommendations possible since there are really no clinical trials that have been done, and there's no RDA or upper limit in terms of safety. There are multiple published reports of adverse effects, including optic neuropathy, seizures, vasculitis, and blood disorders. It can interact with certain medications, and chronic use can lead to a condition called argyria, in which the skin becomes bluish gray. And this is a startling photograph, but this is a guy who was actually, he was on the Today Show about 10 years ago. He had used colloidal silver for a number of years in a row, and it turned him blue. And so the bottom line is, the FDA says colloidal silver isn't safe or effective, for treating any disease or condition. The NIH says it has no known functions or benefits in the body when taken by mouth. And the Mayo Clinic says it's not considered safe or effective. No sound scientific studies have been published in reputable medical journals. So colloidal silver is probably a little bit doubtful. Last three, very quickly, hesperidin is a flavonoid. It's found in citrus skins. There are several studies which show that it binds strongly to the spike protein of SARS-CoV-2, but there have been no clinical trials, and it's really just based on that one finding in cell culture. So there are some trials underway. It holds promise, but at this point, we didn't feel like it was far enough along in its development. Licorice root has been long regarded as a potential source of immune support. And there are some studies which demonstrate antiviral activity, but our board, when they looked at licorice root, they felt that there were really too many issues and safety concerns that might be associated with long-term use, like low potassium levels, hypokalemia, hypertension, and kidney issues. And so because some patients may take a product for long-term, we kind of shied away a little bit from licorice root. Finally, astragalus, which has a long history of use in Chinese medicine with many, many benefits, including immune support. Although there are no studies that have actually looked at looked at viral infection. The main issue for our board was every one of our products goes through independent content certification of what we believe to be the bioactive components. And the problem with astragalus is that there are over 100 different possible bioactive components. And so there was no way that we could potentially assay, we could know what to assay and then content certify. So we ended up sticking basically with the 5 nutrients that were in the EVMS COVID-19 protocol: vitamin D, vitamin C, zinc, quercetin, and melatonin. And we produced a product which is called Theravir. And it was released about 2 weeks ago. Theravir is essentially adapted from the protocol that EVMS proposed, although we modified certain things, a multi-nutrient supplement that provides both immunomodulatory and antiviral activity. Adapted from that medical school COVID-19 protocol, it was approved by our board several weeks after we started working on it. And the formulation includes 2,000 units of vitamin D3, 500 milligrams of vitamin C, 40 milligrams of zinc picolinate, 500 milligrams of quercetin, 2 milligrams of melatonin, and 2 milligrams of copper. Now, the copper we added simply for safety's sake. There's no evidence of antiviral activity or immunomodulatory activity from copper. But because of the high doses of zinc, we wanted to have copper there to avoid copper deficiency with long-term use. Our products all go through independent third-party content certification at NSF International, which is a voluntary nonprofit organization that's based in Ann Arbor, Michigan. And our products get independent lab analysis there. And we assay our products for their bioactive ingredients. And so when we create a product that has herbal content, we want to know what the bioactive component of that herbal product is so that we can assay for that specific metabolite. And so we go through NSF certification with our products. And in terms of clinical use, the total daily dose of vitamin D is only 2,000 in Theravir. And so a patient may need to be started on a higher dose initially if their baseline is low. For Theravir, routine prophylactic dosing is just 2 capsules by mouth daily. Best to take it at bedtime with food if possible. For post-exposure prophylaxis, if you've been exposed to somebody with the illness, or if you develop mild symptoms, you can actually double the dose of Theravir safely for a number of weeks. And so here are the key takeaways. It's a multi-nutrient formulation based on a protocol published by EVMS, a major medical school here in the United States. It provides both antiviral and immunomodulatory activity. It may be appropriate for both prophylaxis and treatment of mild upper respiratory infections. It's safe when used as directed. And I'm going to now turn this over to Ian, who is our National Sales Director, who is going to take you through just a handful more slides to tell you just basically how to get Theravir for your patients if you're interested. Ian, you there?
And as Ian jumps in, I'll remind you guys that we're going to do some Q&A after Ian talks about the product. And then the replay will be on healthyseminars.com/Theralogix, or you can find it on the resource page. And on that page, it lists how to contact Theralogix for the handouts to this webinar, and they have some specials as well. So that's all on the site to contact Theralogix. Ian, go take it away, please. And
Yeah, thank you, Lauren, and thank you, Mark. I'll just quickly mention the cost to the patient of our product, Theravir, is $55 for a 90-day supply. That's in the U.S. It is available in Canada as well. And for you folks that are joining us from overseas, please reach out to us via the contact link on the Healthy Seminars landing page, and we can find ways to work with you as well. Also, too, we have various programs available. There are wholesale programs, affiliate programs. Many of you are familiar with FullScript and other outfits like that. We have a similar program through Theralogix. We offer referral forms. We also have a digital referral app where you can recommend the product via a paper referral slip or electronically via our app. And we're glad to help you set up with those products. We ship directly via USPS in the States, and also Canadian mail we use as well. We have auto refills that occur every 90 days, but the patient can purchase a one-time purchase as well if they wish. And then if you'd like to learn more or get started with us or have any questions or requests from this talk today, you can go to providers@theralogix.com. You can also call the phone number here, 301-778-5050, and we'll get back in touch with you and honor your request. You can also go to the healthyseminars.com/Theralogix landing page and follow the link there to submit your information and request as well. So thanks for joining us, and I'll turn it back over to Lauren and Mark, and they'll entertain your questions. Thanks again.
So again, if you're looking for information on the product last time, what do you guys call your product last time? The PEA that you talked about? And
Canabrex?
Canabrex.
Yeah.
So Canabrex, and then this one as well. Again, you can contact Theralogix. They're running a special until the end of July. If you want the handouts for one or other or both, then again, Theralogix said they're happy to share that with you. I think they're making some pictograms as well that we're going to put up on our landing page for you guys as well. And again, just contact Theralogix for that information. Again, I'm Dr. Ratner. Thank you very much for this information. I like hearing the data, the research. Just to let you guys know, stay tuned, stay subscribed. As I mentioned, I've had Dr. Ratner speak at the Integrated Fertility Symposium, and we're going to have him kind of bust open the research and stuff on reproductive health and PCOS with stuff around minoxidil. And so we're going to ask him to come back and give us a discussion probably in the later June or July of 2020. I'm always interested on the fertility side of it. So please stay tuned. And again, thank you guys for your questions. That was great. Theralogix, thank you for sponsoring this webinar. And Mark, thank you again for putting together this presentation.
My pleasure. Thank you.
The replays are available on healthyseminars.com/Theralogix to both of these webinars. Thank you guys, and stay well and stay safe.
Good night.